Hello again. So last time we went over a video, or you watched a video, we went over the ratios of trig. Remember, I kept going so ka toa and stuff like that. Anyway, today we're gonna kind of be doing that, except a little bit different. Let me start with an example. Let's draw ourselves a cute little triangle. Make it a right triangle and go 3, 4, and 5. And let's make this angle theta. Now, if I asked for any ratio of trig, you guys could probably give it to me if you went SOHCAHTOA. If you did SOHCAHTOA, stuff like that, you could probably get it. I'm pretty sure you could. You watched that video enough times, didn't you? You're good at it now. Yeah, right, whatever. Anyway, so I think I'm going to change it up a bit today and set you guys with a big old nice table over how this should be done. So let's do all these examples from the angle theta. This one right here, that's a funny Greek symbol. It stands for the angle, blah, blah, blah. Now, if we wanted to find sine of theta, we could easily do it because sine is opposite over hypotenuse. So it's 4 because this is the opposite and the longest side is the hypotenuse. So it's 4/5. We know that one. Now, if we wanted to find cosine of theta, we would do cosine of theta equals, now cosine is, oops, I did not mean to do that. Cosine is adjacent over hypotenuse. So we have the 3, which is the adjacent because it's right next to it. And then, once again, the hypotenuse is 5. So 3/5. Now, finally, as you guys well know, tangent is opposite over adjacent. So we have opposite 4/3. Tangent of theta equals 4/3. Opposite over adjacent. Yep. Now, I'm going to throw you guys a couple oddball ones that I want you to figure out. Now, you're probably thinking, what does ksk mean? Ksk actually stands for cosecant. Now, what cosecant is it's the inverse of sine. It's the inverse of the sine function. Now, that sounds really complicated and really annoying, but it's actually extremely simple. All it is instead of taking the opposite over the hypotenuse of sine, since cosecant is sine's inverse, then we just take the reciprocal of this, or the inverse of that. So instead of having opposite over hypotenuse, you now have hypotenuse over the opposite. So instead of being 4/5, you're going to have 5/4, which easily makes a bunch of sense if you pay attention, even in the least. Because all you're doing is, instead of having the opposite over the hypotenuse, you now have the hypotenuse over the opposite. The same goes for secant and cosine. Secant is cosine's inverse, so it's going to have the inverse of the ratio. Instead of being adjacent over hypotenuse, it's going to be hypotenuse over the adjacent. So you're going to have 5/3. Same thing goes with cotangent to tangent. It's the inverse of it. So instead of having opposite over adjacent, you're going to have adjacent over the opposite. Going to have now 3/4. Now, this seems really confusing, but if you set it up with this chart with SOHCAHTOA, and they're all kind of split up, don't worry about this line. And they're all kind of split up, and then you put sine underneath so, cosine under ca, and tangent over toa. Just remember that cosecant is sine's inverse. Secant is cosine's inverse, and cotangent is tangent's inverse. These two are really easy to remember. They're the only ones with t's. These ones I know are a bit difficult to remember, but you're going to have to write it down. That's the only way you're going to be able to really figure this out. Let's take another example real quick. Let me just scroll down a little bit. Now, let's make ourselves another right triangle. Except now let's have do 5, and let's have 13 up here. Let's do angle theta from this angle. Now, remember that because angle theta is in here, the 5 is now the opposite because it's the farthest away from the angle. 13 is still the hypotenuse. It's the one across from the 90-degree angle here, and it's always the longest side. So that's easy to remember. Now, real quickly, let's find the sine of theta. Now, if you remember, sine is so opposite over hypotenuse. You simply have 5 over 13. And let's make this side here x. Now, let's do tangent of theta. Tangent of theta is going to be opposite over adjacent. So you're going to have 5 over x. Let's throw another oddball in there. Let's go secant of theta. Let's think secant. Is secant sine's reciprocal? Sine's inverse? Of course not. See, if you go right back up here, you see that secant is cosines. So, if you were to do cosine of theta, you would have adjacent over hypotenuse, x over 13. But we want the opposite of that, so it's going to be 13 over x. Now, Mr. Hemphill has me do a lot of homework for this. I'm his peer counselor, and that's why I'm making these videos for you guys. But I want him to start doing a little bit of homework on his own for himself. If you guys have any questions, any comments, any concerns, any sarcastic remarks, anything to mention about this video, feel totally free to comment on it in the comment section right below. It's right below the video. You can type in whatever question it is, and Mr. Hemphill will find it for you guys. All right, until next time.